Good morning, students. Myself, Vijay Shankar from Electronics and Communication Engineering Department, Chibdol Engineering College. Today, we are going to discuss about the properties of Fourier series in signals and systems. The previous class, we already discussed about the some properties of Fourier series, the linearity property, time shift property, and frequency shift property, scaling property, and the time differentiation property. Totally the 5 properties of the Fourier series we completed. The linearity property of Fourier series, time shift property of the Fourier series, frequency shift property of the Fourier series, and scaling property of the Fourier series, and also the time differentiation of the Fourier series. Today we are going to discuss about the remaining Fourier series properties, that is the convolution in time. Convolution in time. Before going to discuss about the convolution in time, the property of Fourier series, you have to know what is the convolution. What is a convolution? And what is the formula you have to use for the continuous time signal and the discrete time signals. Okay. So convolution integral. Convolution integral. Convolution integral. This is for the continuous time signal. For continuous time signal, we are using the convolution integral. For discrete time, we are using the convolution sum. Convolution sum. With convolution of is an asterisk, the convolution symbol, and y of t is equal to, and here the discrete time function, the x of n, the variable is changes here, the convolution of y of n is equal to, here we are using the sum of n is equal to, not the n here, k is equal to minus infinite to infinite, and the convolution integral minus infinite to infinite, or you take it as a t, integral t, x of tau, y of t minus tau, d tau. Okay, and here the sum of k equal to minus infinite to infinite, x of k, y of n minus k. But also, this equation can also written as sigma k is the sum of k is equal to minus infinite to infinite, y of k, x of n minus. So both are the same. Okay, because the convolution obeys commutative property. What is the commutative property saying? AB is equal to BA. AB is equal to BA. So I'm interchanging X as a Y here and Y as X here. So the commutative property is saying AB is equal to BA. Understood? So the convolution obeys the commutative property. We can also use the X of K, Y of N minus K, or the Y of K, X of N minus K. And this is the equation we got from the actually the causal and the non-causal signals. So the continuous time signal and the discrete time signal, again it is classified as periodic, non-periodic, even and odd signals, deterministic and the random signals. Okay. Energy and the power signal. The another we have the causal and the non-causal signals actually. Causal and non-causal signals. So what is a causal and non-causal signals? First of all, causal. Suppose if I am taking the two equations, causal means simply you can say h of n is equal to 0 for n is less than the 0 value. Means h of for negative values for negative values of n, the h of n, the unit impulse signal, the h of n is equal to 0. When this condition is satisfied, the causal signal, causal, okay, means h of n, h of n minus k, not the n, it is a k value, x of k, h of n minus k, and so on. In this, the sum of k is equal to minus infinite to infinite. We can expand this function from the minus infinite to infinite. The negative values of k, here it is a k actually. The k is h of n is equal to 0 for n is less than the 0. Or we can also write it as sum of k equal to minus infinite to infinite h of k, x of n minus k. Now I can expand these functions so on, so on, so on. H of minus 1, x of n minus of minus 1 becomes is a plus 1, plus the next value, if I am taking the h of 0 as a k is equal to 0, x of n minus 0, and next function, if I am taking the h of 1 as a k is equal to 1, x of n minus 1, plus so on, is a function. I'm taking all the negative values. I'm showing here only the minus 1, 0, and 1. Substituting the k is equal to minus 1 here. H of minus 1, x of n minus of minus 1 becomes a plus x of n plus 1. Plus h of 0, x of n minus 0, plus h of 1, x of n minus 1. When we can choose a causal, it depends upon the present inputs and the past inputs. What is the input here? X is the input. X is the input. If X is the input, X of n is the input. X of n is a present. X of n is a present. and x of n minus 1 is a past, and x of n plus 1 is future. Okay. So when we can call it as a causal, it depends upon the present input x of n, and it is also depends upon the past inputs of x of n minus 1. It is not depends upon the future input. So to get the negative values, all the negative values becomes a 0. The input is not at all equal to the 0 because here the input is there. The previous, before the value is a h of minus 2. H of minus 2 and the x of n plus 2. Okay. And here the h of minus 3, x of n plus 3. Means towards the left side up to the minus infinite, the input value is future inputs only. X of n plus 1, n plus 2, n plus 3 and so on. So the input is not at all equal to the 0, but these terms to become a 0 value, so when we can substitute the h of n is equal to 0 when n less than the 0 value. See here, when n is equal to, I'm taking the minus 1, h of minus 1 is a 0. When n is equal to minus 2, h of minus 2 is a 0. When n is equal to minus 3, h of minus 3 is a 0. So all the future inputs with the multiplication factor of h of n is equal to 0 for n less than the 0 values is a causal and the non-causal. If this condition is satisfied, we can call it as a causal. Not satisfied means the feature, it is also depends on the feature inputs, non-causal system. Okay. Coming to here, in the convolution in time, we are using the convolution integral formula. What is the convolution integral formula? The x of tau, y of t minus tau d tau. Okay, let's go the proof of the convolution in time. Convolution in time. Okay. What is the statement saying? If x of t is a Fourier series x of k and y of t, the Fourier series y of k, then the convolution of z of t is equal to the convolution of the two signals x of t with convolution of y of t is a Fourier series of Fourier series z of s is equal to x of k into y of k, x of k into y of k. So let us go for the proof. Okay. This is saying that z of s is equal to z of s is not the s, sorry. It is not the s, k value, my dear students. Z of k, z of k is equal to 1 by t integral t. Listen carefully, my dear students. 1 by t, the integral t, z of t, e power minus jk omega naught t is the formula for analysis equation. Okay, by the exponential Fourier series analysis equation. So what is the z of t here? So that is equal to 1 by t, the integral t, z of t as a convolution between of x of t and y of t, e power minus jk omega naught t dt, omega naught t dt. I can represent x of t, the convolution of y of t, as convolution integral 1 by t, the integral t, and this is also the 1 by t, the integral t, x of tau, y of t minus tau, d tau, as a formula for x of t with the convolution of y of t, into e power minus jk omega naught t dt. Okay, my dear students. Now bring all the tau terms and the t terms separately. So 1 by t, the integral t, x of tau, d tau. Another integral I am using here, 1 by t, the integral t, y of t minus tau. Here also the t is there, e power minus jk omega naught t dt. Separate all the here, the t is there, this also the term t and the t. Now you can see here, these are the two functions we got from the above equation. It is just look like as a time shift property. Instead of x, here the y is there, yt minus tau, t minus t naught is there. T minus t naught, instead of t naught here the tau. Or otherwise, you can assume t minus tau is equal to m, as usual what we did in the time shift property. Or otherwise, by using the time shift property, you can replace this total in the parenthesis as e power minus jk omega naught t naught, actually instead of t naught here the tau into dt, not the dt, y of k. Otherwise, without knowing that t minus tau is equal to m, we can assume, apply the derivative on both sides as the tau is a constant here, dt is equal to dm. dt is equal to dm. And what is t here? T is equal to m plus tau. T is equal to m plus tau. Replace these values in the second parenthesis what we have here. I'll show in the next page. And z of k is equal to, as of 1 by t, the integral t, x of tau, d tau, as a first parenthesis, and second parenthesis have 1 by t, the integral t, y of t minus tau, the t minus tau replaced as m e power minus j k omega naught t as t plus tau, not the t plus tau, m plus tau, m plus tau, and dt as a dm. Okay, my dear students. So the t minus tau I replace with the m here, and t t as a m plus tau, and dt as a dm. Okay, is totally within the parenthesis, is equal to 1 by t the integral t x of tau d tau as of the one function here, and this one is a 1 by t integral t y of m. I'm separating the two functions here, then the power as a plus is there, e power minus j k omega naught m into dm. Okay, I use this function as a one function, and the remaining factor here e power minus j k omega naught tau, e power minus j k omega naught tau. See, this total function is similar for the analysis equation. What we have, x of k is equal to 1 by t integral t y x of t e power minus j k omega naught t dt. Instead of t here the m is there, instead of x here is a y. So you can write it as a y of k, 1 by t integral t x of tau d tau as one function, and this total function will get as y of k as a Fourier series formula only, into e power minus j k omega naught tau, and rewrite this function again, is equal to 1 by t the integral t x of tau. So bring this function is inside, e power minus j k omega naught tau and d tau. Keep it as one function, and y of k. Now you can observe this function is also similar to this analysis equation, 1 by t the integral t x of tau e power minus j k omega naught tau d tau. Instead of t, here the tau is there. Here instead of t, m is there. So y of k. Here the x, it becomes of x of k. X of k into y of k. F of k into y of k, as z of k is equal to we got x of k into y of k. What the this is z of k is equal to x of k into y of k. Means the time is convolution time. The time is convolution. Product in frequency. Product means multiplication. The time is convolution in the two signals, the product of the frequencies of the two signals. After applying the Fourier series in between, the convolution in time is a very, very important property. To see that convolution. So here also you can observe z of k is equal to 1 by t, the integral t, 1 by t, the integral t, z of t e power minus jk omega naught t dt. And 1 by t, the z of t have to take as the convolution between of the two signals, x of t, y of t. So x of t with the convolution y of t e power minus j k omega naught t dt. What is the convolution of x of t and y of t formula is x of t, the convolution of y of t, 1 by t, the integral, 1 by the integral x of tau y of t minus tau d tau. So there is no 1 by t here, my dear students. Okay. This convolution is performed over one period for periodic signals. This convolution is performed over one period for periodic signals. And substituting the x of t with the convolution of y of t here, this formula. See, z of k is equal to 1 by t, the integral t x of tau y of t minus tau d tau e power minus jk omega naught t dt. Interchanging the order of integrations, I'm taking the 1 by t, the integral t x of tau as a tau functions, remaining the integral t y of t minus tau e power minus jk omega naught t dt and the d tau. You can write here, it is directly the d tau. Okay. See, as usual, by substituting t minus tau is equal to m, therefore dt is equal to dm. Since integration is over one period, this substitution will just shift the integration limits, but it will be again over one period only. Hence, we can write it as z of k is equal to 1 by t, the integral t x of tau, and the integral t minus tau is equal to m here, e power minus jk omega naught, the t, now it is tau plus m, or m plus tau d tau, and the dt is equal to dm. Okay. So 1 by t, the integral t x of tau, integral t y of m e power minus jk omega naught dm tau e power minus jk omega naught m d tau and the dm. So y of m e power minus jk omega naught dm as a y of k. And 1 by t, the integral t x of tau e power minus jk omega naught tau d tau is a x of. So actually we have only the 1 by t, my students. I explained here. I substitute the 1 by t. There is no any 1 by t for here. 1 by t. There is no any 1 by t in the convolution. So remove that 1 by t. Then the second page also remove that 1 by t here. 1 by t. So this function is y of k. And here there is no any 1 by t, and here there is no any 1 by t. To keep the 1 by t here, 1 by t, and multiply the t here. Multiply the t. T. This function has x of k and y of k. There is a t is also there. T into x of k, y of k. You have to prove that the t into x of k, y of k. T into x of k, y of k. There is no any 1 by t, the function in the convolution formula. X of t, convolute the y of t is only integral t x of tau, y of t minus tau d tau. And this t, you can multiply here the 1 by t and the t function. Understood? So final z of k is equal to taking off 1 by t, the x of tau, e power minus j k omega naught tau d tau as x of k, and integral t y of m e power minus j k omega naught m dm, and if there is 1 by t, then only it is a y of k. There is no 1 by t, keep that here the 1 by t, and multiply the t here for this total function. Okay. Then the t into x of k, y of k. Z of k is equal to x of k, y of k into t. Okay, my dear students. So here you have to prove the z of t is equal to x of t with the convolution of y of t. Apply the Fourier series for the time convolution or the convolution in time. The frequency becomes z of k is equal to t into x of k, y of k. T into x of k, y of k. So very important property. And next, coming to the multiplication or the modulation theorem. Multiplication or modulation theorem. Statement saying that if x of t is a Fourier series x of k and y of t, the Fourier series is y of k. Now observe here, the time is product or the time is multiplication. What is the frequency here? Frequency is convolution. Here the convolution symbol it is. Frequency is convolution. Previously in the convolution time is convolution, frequency is multiplication. X of k, y of k with the t. T is also there, capital T, the time period. But in the coming next property, the multiplication or the modulation theorem saying that the time is multiplied. The multiplication in time, the timer, the two signals x of t and y of t, the time signals is multiplied or the product. For that, the Fourier series, applying Fourier series of x of t, the y of t, the convolution of the two frequencies. For x of t, the x of k is a Fourier series. For y of t, y of k is a Fourier series coefficient. And x of k, y of k convolution for the multiplication of x of t and y of t. Okay. Let us take the same way you have to prove by taking off analysis equation here. Analysis equation z of k is equal to 1 by t the integral t z of t e power minus j k omega naught t dt. As per the definition saying that exponential Fourier series in that analysis equation. Here for this multiplication and modulation theorem, you can use both the analysis equation and the synthesis equation. Both the analysis equation and the synthesis equation. Now let us see. I'm taking another one. Multiplication or modulation. Multiplication or the modulation theorem for the property. Okay. So what is the statement saying here? If x of t, the Fourier series, x of k, y of t, the Fourier series, y of k, is the multiplication in time, then prove that when the z of t is equal to the multiplication of the two signals x of t, y of t, its a Fourier series is z of k is equal to the x of k convolution of, this is a convolution, my dear students, it's a symbol. So let us see here. Convolution of y of k. This time is multiplication, convolution is the frequency. Okay, let us go for the proof. According to the analysis equation, z of k is equal to 1 by t the integral t, 1 by t the integral t, z of t e power minus jk omega naught t dt, omega naught t dt, and is equal to 1 by t the integral t. What is the z of t? Taking out the multiplication of the two signals, time signals, y of t, x of t, and y of t, e power minus jk omega naught t dt. Okay. In this, you can substitute the x of t by the synthesis equation. On the synthesis equation, x of t is equal to sum of k equal to minus infinite to infinite, x of k is a positive exponential, e power plus jk omega naught t. So replace the x of t with this equation, analysis equation, not the synthesis equation. So z of k is equal to, now the above equation becomes z of k is equal to 1 by t, the integral t. Now I am taking here the x of t as sum of k equal to minus infinite to infinite, x of k e power jk omega naught t. Let's take as a one function and replace only the by x of t here. Okay, and y of t, write as directly the y of t e power minus, and this function here, e power minus jk omega naught t dt, omega naught t dt. What I did here, replace the x of t by the synthesis equation in exponential Fourier series. What is that equation? X of t is equal to sum of k equal to minus infinite to infinite, x of k e power jk omega naught t. Now again rewrite this function, z of k is equal to, see, I take the 1 by t the integral t, 1 by t the integral t, e power minus jk omega naught t, 1 by t the integral t, e power minus jk omega naught t, 1 by t the integral t, e power minus jk omega naught t, 1 by t the integral t, e power minus jk omega naught t, 1 by t the integral t, e power minus jk omega naught t, 1 by t the integral t, e power minus jk omega naught t, 1 by t the integral t, e power minus jk omega naught t, 1 by t the integral t, e power minus jk omega naught t, 1 by t the integral t, e power minus jk omega naught t, 1 by t the integral t, e power minus jk omega naught t, 1 by t the integral t, e power minus jk omega naught t, 1 by t the integral t, e power minus jk omega naught t, 1 by t the integral t, e power minus jk omega naught t, 1 by t the integral t, e power minus jk omega naught t, 1 by t the integral t, e power minus jk omega naught t, 1 by t the integ 1 by t, the integral t, and we have the y of t is there, y of t, and e power minus jk omega naught t dt. Total 3 terms, not the 3 equations here. Y of t, the e power minus jk omega naught t dt. Understood? So what is the remaining here? Whatever the branches is there, the sum of k equal to minus infinite x of k e power jk omega naught t. X of k, sum of also that. Sum of k equal to minus infinite x of k e power plus jk omega naught t omega naught t. Okay, my dear students. See, here you can observe the e power minus jk omega naught t, and here e power jk plus omega naught t. You have to get cancelled. If we get cancelled, we didn't get the x of k with the convolution of y of k. Now, a small modification you have to do. Instead of k here, instead of k, once again I'm saying, instead of k, you can keep it as m is equal to minus infinite, m is equal to minus infinite, x of m, j m omega naught t. Don't confuse my dear students. Simply, because of, you see the e power minus jk omega naught t and e power minus plus jk omega naught t. Both the bases are the same. Powers you have to add. And this one is a plus and this one is a minus, it becomes of e power 0. That value is a 1. But by using these remaining equations, whatever you have in the z of k, the x of k, and the convolution of y of k, you will get that one. So, I replace that k as m. Okay, k as m. So, modified here also the k and k here. K also. K as m is equal to minus infinite x of m e power jm omega naught t. Follow my students. Now here also I change it is m values. M is equal to minus infinite x of m e power jm omega naught t. Now there is no any cancellation here for the e power minus jk omega naught t, and here the e power jm omega naught is equal to sum of m is equal to minus infinite x of m, and another equation here 1 by t, the integral t y of t e power, take the common here, minus j omega j, let us take is a minus here, k minus m, k minus m, minus into minus here, the plus, minus j here, omega naught t. omega naught t, and this function is also the dt. Alright. So observe here this total equation as the frequency shift property saying that k minus k naught 1 by t the integral t y of t e power minus j k minus m omega naught t dt according to the frequency shift property. And this total equation according to the frequency shift property, the sum of n is equal to m is equal to minus infinite to infinite x of m. Now this total equation we write as according to the one of the property, frequency shift property, x of k minus k naught. When here it is a x of t, now it is a y, take it as a y, k minus k naught, k is there and k naught is not the replace as a m value, k minus m. Sum of m is equal to minus infinite to infinite x of m y of k minus m. See, this is the equation z of k is equal to convolution sum. The convolution integral as integral t y of x of t x of tau y of t minus tau d tau. As a convolution sum saying that convolution sum. Convolution sum. What is the convolution sum? The sum of k equal to minus infinite to infinite x of k. Not is a small letter, it is a capital letter. X of k y of n minus k. See, after these two equations now, instead of k, here the m. X of k, y of n minus k, and here the m. Instead of k, n, here the k value. Both are the same. So what is the relation here for these two equations? The relation is x of k with the convolution of y of k. X of k with the convolution of y of k. Z of k is equal to. Means the input, the time signals is multiplied. The Fourier series of the product of the multiplication of R, it is a modulation of the time signals. In the frequency, the signals convolution. X of k with the convolution of y of k. So x of t, the y of t, the product of the two time signals, its Fourier series is x of k with the convolution of y of k. X of k with the convolution of y of k value. Understood? It is also very, very important, my students. Now see how explain this. This is the multiplication of modulation theorem. X of t, the Fourier series is x of k. Y of t, the Fourier series is y of k. Taking off the product of x of t, y of t, its Fourier series is convolution of x of k and y of k. First I take the analysis equation, z of k is equal to 1 by t, the integral t, z of t e power minus jk omega naught t dt. And the z of t take as x of t and y of t, 1 by t, the integral t, x of t, y of t, e power minus jk omega naught t dt. By the synthesis equation, see here, by the synthesis equation, x of t is equal to sum of k equal to minus infinite to infinite x of k e power j k omega naught t, j k omega naught t. So now, putting this expression for x of t in the above equation, x of t in the above equation. See 1 by t. See already is without doing any other expressions here, directly they given 1 by t the integral t x of tau e power minus j k omega naught tau d tau integral t y of m e power minus j k omega naught m and dm. They already modified. So keeping of this equation, so z of k is equal to, it becomes of what I explained the whiteboard here, z of k is equal to 1 by t, the integral t, the x of t, you can keep it as x of t is the sum of k equal to minus infinite to infinite, x of k e power j k omega naught t is multiplied here, and y of t e power minus j k omega naught t dt. So here they replace the m, y of m e power minus j k omega naught m and the dm with 1 by t, the integral t. And the summation of x of k e power j k omega naught as modified with k as, here is the m, k as the m value. Then it becomes of 1 by t, the t x of k and the t into y of k. Why they dot? It is a t into x of k and the t into y of k. Directly they take it as x of tau, the e power minus j k omega naught tau d tau. The function as x of k function is a x of k function. And this function is also with the y of m e power minus j k omega naught m dm. With 1 by t is there, it is a y of k. There is no any 1 by t, can multiply with the t here. Okay. And this total 1 by t, directly they can take in 1 by t. For this function, 1 by t you have to get. Otherwise, you can multiply the t into x of t. And here also 1 by t with this function, with the y of k. There is no 1 by t, so multiply the t. So keeping the 1 by t here and multiply the t. And for this function also 1 by t multiply with the t. So 1 by t the integral t x of tau e power minus j k omega naught tau d tau is a t into x of k. And this function with the t into y of k. So t get cancelled, the t into x of k, y of k. So this is actually for these two equations. These two equations actually for this convolution in time, my dear students. Convolution time. Let us will modify that. So these are the two equations for the previous one. Now you can see these are the two equations. Is a little bit confusion. Now you can see. Is a 1 by t the x of tau e power minus jk omega naught tau d tau here, and integral t y of m e power minus jk omega naught m df. So 1 by t they directly written here, and for this function it is a t can multiply here and 1 by t, so t into x of k, and t can multiply here 1 by t into y of k. So t x of k y of k. It is a convolution time proof. The multiplication factor, multiplication, the modulation theorem. So the x of t is substitute as the sum of m is equal to minus infinite to infinite x of m e power j m omega naught t. So directly taken as a k as a m. What we taken in the previously I explained here. See the sum of m is equal to minus infinite to infinite x of m e power j m omega naught t instead of k. They replace as a m as a variable. M as a variable. So sum of m is equal to minus infinite to infinite x of m e power j m omega naught t. And the remaining function, the y of t e power minus jk omega naught t dt. Okay. Note that the index of the summation is changed in the above equation to differentiate between two indices. See, these two indices is the same. Whenever if you can take is a k value. The two indices of k here and m interchanging the order of integration and summation. So by keeping directly without changing the m variable by as a k, in terms of e power 0, the value is 1. Okay. The index of the summation is changes in the above equation to differentiate between the two indices of k and m. Here the k is there and here is m. Now we can interchange the order of the integration and the summation. Integration here is a y of t and summation in the x of m. See here. The sum of m is equal to minus infinite to infinite x of m 1 by t the integral t y of t e power minus j k minus m omega naught t. K minus m omega naught t. Whatever the total equation is in the parentheses we here in the brackets, according to the frequency shift property, the quantity inside the bracket indicates Fourier coefficient to y of k minus m. Y of k minus m. Hence the above equation will be z of k is equal to sum of m is equal to minus infinite to infinite x of m, and this total quantity inside the bracket is of y of k minus m according to the one of the property, the frequency shift property. And this equation, what we have here, the sum of m is equal to minus infinite to infinite x of m y of k minus m as the convolution sum formula. The convolution sum formula. So what we already seen here, the convolution sum of k equal to minus infinite to infinite x of k y of n minus k. As a k has here the m and n as a k. So x of k with the convolution of y of k. So z of k is equal to x of k with the convolution of y of k. Understood, my dear students? Now, is a very, very important two properties today we see. One is convolution in time, and another one is a multiplication or modulation theorem. The conclusion of the two properties is x of t convolute with y of t, its Fourier series is t into x of k, y of k. Means time is convolution, frequency is product. The convolution in time. Convolution in time. Okay. Now the modulation or multiplication. Multiplication. So the time is product or the multiplication y of t x of t. Its Fourier series is frequency is convolution. Frequency is related with the convolution. Okay. So inverse. Time is convolution, frequency is product. If time is product, frequency is convolution. So these two properties are very important. You have to learn, practice this one. 2 or 3 times you have to practice, then you can get without any ambiguity. The x of t, the convolution of y of t, and the t into x of k, y of k. And the multiplication and the modulation theorem, x of t, y of t with the Fourier series, x of k with the convolution of y of k. Following my students. And the last property we have here, the last property is the Parseval's theorem. Parseval's theorem and the symmetry properties. So it is not the property, but here are some equations are there and the symmetry properties. Parseval's theorem and the symmetry properties. After that, there is some examples you can see in the tomorrow's class. Okay, you can see in the tomorrow's class, my students. So what we discussed now, the convolution time and the modulation or the multiplication theorem. So now we completed the properties of the Fourier series are, first one is a linearity property. Second one is time shift property. Third one is a frequency shift property. And the fourth one is a scaling property. And the fifth one is here, differentiation in time. So these are the properties, the linearity property. Second one is time shift property. Third one is frequency shift property. And fourth one is a scaling property. And the fifth one is a time differentiation property. Today we discuss about the two properties, the very important properties, that is convolution in time, the sixth property. And seventh one is multiplication or the modulation theorem. Multiplication or modulation theorem. And eighth and the ninth properties is a Parseval's theorem and the symmetric properties, and some examples are there. By using these properties, we can discuss in the tomorrow's class, my students. Okay. Tomorrow means the day after tomorrow, that is on Monday. So any questions? Any questions on the Fourier transformations? The total 7 properties. Not the Fourier transformation, it's the Fourier series, my dear students. Sorry. The properties of Fourier series, the 7 properties. Okay. Thank you. Thank you, one and all.